Good morning, students.
Morning, sir.
Yeah, morning to all. Shall we start the class?
Yes, sir.
Okay. Today, our concept is first law of thermodynamics. First law of thermodynamics. So, before going to the first law, we have to know about the concept of internal energy. Okay. So, what is meant by internal energy? So once if we finish this internal energy, then we can go for first law of thermodynamics. What it mean by its internal energy means. So first of all, if you take the system, okay. So a gas enclosed in a cylinder. This is a glass enclosed in a cylinder. So we can call it as. This is the region which is a collection of large number of atoms and molecules. We can call it as a system. Okay, we can call it as a system. So, if the molecules are static or randomly moving, means molecules are randomly moving. So, because of that molecular motion, the system have internal total kinetic energy. And between the molecule and another molecule, there is a kind of force is there that is called molecular forces. Because of that molecular forces, there exists a potential energy between the two molecules. So then, if you consider a system, due to that random motion of the molecules of the system, all the molecules will have kinetic energies because of that random motion. And between a molecule and molecule, there is a molecular forces exist between the molecules. Because of that molecular forces, potential energy will be there. So therefore, internal energy is, if I take the letter U, means internal energy is equal to the sum of internal energy due to the kinetic interpretation and internal energy due to the potential interpretation. So this UK is nothing but energy, internal energy due to the molecular motion of the motion or random motion of the molecules, and this UB is nothing but potential energy because of the molecular forces between the molecules. Okay. That is about internal energy. Every system will have some internal energy. So why the system will have internal energy means the system is a collection of large number of atoms and molecules. As you know that one atoms and molecule will not be static. The atoms randomly keep on moving throughout the volume of this vessel. So while keep on moving, each and every molecule will have some kinetic energies. The sum of all kinetic energies due to the motion of the molecule is called UK. And between a molecule and molecule, there exists some force is there. That force is called intermolecular forces. Because of that intermolecular forces, the potential energy will be exist. This is called potential energy. The sum of all the energies that the system will have, that is called internal energy. Internal energy will have almost it is the sum of kinetic energy plus potential. So this is about the Internal energy concept. Internal energy is a function of temperature. As the temperature is increases, what will be happening means the random motion of the molecules is also increases. The speed of each and every molecule increases, which causes increase in kinetic energy of each molecule. Because of that, internal energy will be increases. As the temperature is decreases means as the temperature is decreases means the kinetic energy of the molecule is decreases because the speed of each molecule is decreases. As the temperature is decreases. If you brought to 0 Kelvin, then this UK becomes 0. UK becomes 0. Their potential energy is due to their internal energy is due to only the potential energies. Internal energy is only due to the potential energy. So internal energy is a function of temperature. As the temperature is increases, the internal energy will increase. As the temperature is decreases, internal energy will get decreases. At 0 Kelvin, the molecular motion of the molecule will ceases. That's why internal kinetic energy will be 0. There, the internal energy is only equal to the internal potential energy of the system. So this is about when the temperature is constant means if T is equal to constant, then internal energy will neither raises nor falls. It will also constant. So this is about the concept of internal energy. Every system will have some energy that is called internal energy. Why the system will have internal energy means system is a collection of large number of atoms and molecules. So if you take the vessel, okay, so if it is a collection of an ideal gas, if you say that a gas, all the gas molecules are randomly keep on moving in different directions. Because of that motion, the system will possess some internal kinetic energy. And between a molecule and another molecule of the system, there exists intermolecular forces will act. So because of that intermolecular forces, already we have studied that intermolecular forces in expansion of solids. So in case of gases also, there exist intermolecular forces will be there. So because of that intermolecular forces, the system will possess internal potential energy. The sum of all the energies that the system will have, that is called internal energy. Internal energy is usually a sum of internal kinetic energy due to the molecular motion of the each and every molecules of the system. And UP is nothing but internal potential energy due to the molecular configuration of the system. Due to the molecular configuration of the system. So this is about internal energy. As the temperature is increases, random motion of the molecules are increases, which causes increase in speed of each and every molecules. So therefore, the internal energy of the system will get increases. As the temperature is decreases, what will happen means molecular motion of the molecule is get decreases. If we keep on decreasing the temperature at 0 degree Kelvin, molecular motion ceases. Molecules will not move at 0 degree Kelvin. On such cases, the system will possess only the internal potential energy only. So therefore, internal energy is a function of temperature. As the temperature is increases, internal energy of the system is increases. As the temperature decreases, internal energy of the system is decreases. If you maintain the temperature constant, then internal energy is also constant. So that is about the internal energy. Internal energy is in single word if you say internal energy is the energy possessed by the system. Okay, energy possessed by the system is called internal energy. Sum of all the energies that the system will have, that is also called internal energy. These are the two types of energies the system may possess. The sum of these two types of energies will be called internal energy, which is a function of temperature. System is a collection of large number of atoms and molecules, as already we have discussed that. Molecules means, as you know, that molecules are keep on moving in different directions with different velocities. So therefore, each and every molecule in the system will have kinetic energies. Then, if you consider all the molecules of the energy, kinetic energy, the system will possess kinetic energy. And between a molecule and molecule, there exists molecular forces there. Because of the molecular forces, the system will possess internal potential energy. The sum of these two energies is nothing but internal. So clear, students?
Sir, how they possess potential energy? Can you explain that once again, sir?
Potential energy. To understand that potential energy, you need to know about electrostatics. For example, here two charges are there that will come in second year. Till then, remember that.
Okay, sir.
Okay. So keeps abiding now. Internal energy. Internal energy. It is the. Are you writing, guys?
Yes, sir.
Yeah,
Yes,
right.
sir.
Yeah, yes, right. It is the energy. It is the energy. It is the energy. It is the energy possessed by the system. It is the energy possessed by the system due to molecular motion and due to molecular motion and molecular configuration. Due to molecular motion and molecular configuration. Due to molecular motion and molecular configuration. Okay, so you can write U is equals internal energy, U is equals to UK plus U. Internal energy U is equals to U plus. There you can write, guys, UK nothing but UK, UP. Beside that UK, you can write there beside that UK. Molecular kinetic energy. Molecular kinetic energy beside UK. Molecular kinetic energy. Next, beside UP, okay, molecular potential energy. Molecular potential energy. Molecular potential energy. Molecular potential energy. Completed, students?
Yes, sir.
So next make a 2-3 points are there. Make a note of this. Internal energy of the system depends upon. Internal energy of the system depends upon. Okay. Internal energy of the system depends upon like this. First one, number of moles. Number of moles. Number of moles. Second one, pressure. Second one, pressure. Second one, pressure. Third one, volume. And fourth one, temperature. The internal energy of the system depends upon number of moles of the system, pressure of the system, volume of the system, temperature of the system. Temperature of the system. Temperature of the system. Temperature of the system. Next one, next point. When the temperature of the system increases, when the temperature of the system increases, when the temperature of the system increases, internal energy is increased. Internal energy is increased. internal energy is increased, comma, du is, what is mean by du means, students, I wrote here, what is a du stands for change in internal energy. Okay, du is positive. Du is positive. Du stands for change in internal energy is positive. That is the point. Finished, students?
Yes, sir.
So next one. Next. When the temperature decreases. Next one. When the temperature decreases. When the temperature decreases. Next point. When the temperature decreases, internal energy, internal energy, internal energy, internal energy is decreased. Internal energy is decreased. Internal energy is decreased. Internal energy is decreased. Comma, comma, du is negative. Du is negative. Du is negative. When the temperature is decreases, internal energy is decreased. Du is negative. Du is negative. Du is negative. Next one, last point regarding internal energy. When the temperature is constant, 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 internal energy is constant. Internal energy is constant. When the temperature is constant, internal energy is constant. Internal energy is constant, comma, du is 0. Du is 0. Du is 0. So students, what is mean by du there?
Change in internal energy.
Yes, change in internal energy. Internal energy of the system is increased, means change in internal energy is positive. That will be happen with rising temperature. Change in internal energy of the system is decreased, means change in internal energy is negative. That will be happen when the temperature of the system decreases. And if the internal energy is constant, then change in internal energy is 0. That will be happen when the temperature is constant. So this is about the internal energy concept. So next one keeps abiding. As you asked intro, what is mean by abide?
Yes, sir.
You asked what is the potential energy means. Next year you can understand, but we will go with one example. If you take the rubber band, if the rubber band is stretched, what will be happen? What you can observe that? So take the rubber, small rubber band. If it is stretched by with your hands, then what will be happen? Rubber band is try to regain its length back or not?
Yes, sir.
Yes, sir.
So it means that inside the rubber, a force is generated or not.
Yes, sir. It's generated.
That force is due to the potential energy between the two molecules. That force is arises due to the force between the molecule and molecule. Molecule, each and every molecule, there exists a force is there. That force is called intermolecular forces. The intermolecular forces is due to the potential energy of this potential energy of the system. If the system will not have potential energy, there exists no force between a molecule and molecule. So if you take the rubber, if the rubber is stretched, means in reverse manner, the rubber band is also trying to drag it back to regain its original length. That is due to the intermolecular forces between rubber atoms, and that intermolecular forces is arises due to the potential energy. If the potential energy is not there between the two atoms, then there will be no intermolecular forces.
Yes, sir, understood.
Regarding that the potential energies, in electrostatics you may learn about the potential energy of the system, or else in case of gravitation also in the potential energy concept. There you can learn in some more detail. Okay.
Yes, sir.
So right, next keeps updating first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. So don't write anything until I count. So I consider this is the system provided with a piston which can able to move slide up and down, as already we have discussed about, which was placed on a heat reservoir or a heat source. Okay. So heat source. So heat source means which can provide heat energy to the system. Okay. Students observe that the system can absorb the heat from the heat source. Let, for example, let the amount of the heat is absorbed by the system. What we can observe that generally, for example, heat is supplied means definitely gas will expand. So while expanding that, it will pushes the piston so that this is the final position of the piston. This is the initial position of the piston. So in this case, the gas done some work also. Gas done some work. So then let dW amount of work is done, which is able to we can able to observe that. Piston is moving means it is visible to us. We can able to observe that the gas is expanding and it will push the piston upward direction. Then definitely one has to accept that by interacting, the system is interacting with the piston and the piston will be pushed back. Means gas has done some work. Let dW work is done. So can I write this dq is equals to dw? Or is there any wrong work? So this work is done by absorbing the heat energy from this heat source. Let dq amount of the heat is absorbed by the system from the source. Due to that, the system is expanded and it did some work. Let dw is the work done by the system. Okay, so then can I write dq equal to dw, or is there any other in this relation? Try to check out. Can I write dq equal to dw? Students respond.
Yes, sir.
Can I write dq equal to dw?
Yes, sir.
So definitely not. Why? Because means the temperature of the system is also increasing or not? Students,
Yes, sir. Yes, sir.
temperature of the system is increasing. After increasing the temperature only, the system is able to push the piston upward direction. So the temperature of the system is increasing means hence some of the energy is absorbed by the system that is used to increase the temperature means definitely dq will not be equal to dw. Something is missing here. What is that something means? Du is the we are missing that. What is mean by du means change in internal energy of the system. Okay. So the heat supplied to the system which is capable of doing work is equals to sum of the increase in internal energy or the change in internal energy of the system and work done by the system. dq is equals to du plus dw. A system cannot do the work without raising its temperature. Definitely, when the heat is supplied to the system, the temperature of the system should be increased first. When the temperature of the system is increased first means internal energy increases. First, the supplied heat or a part of the supplied heat is utilized to increase the temperature. That is nothing but to increase the change in internal energy, to increase the internal energy. The rest of that energy is able to push the piston upward direction. That is nothing but external work done. Hence, heat supplied to the system which is capable of doing work is always equal to sum of the increasing internal energy or the change in internal energy of the system and work done by the system. So therefore, dq is always equal to du plus dw. So students, one thing is just remember that is it possible to push the piston upwards without raising the temperature of the gas inside?
No, sir.
It's not possible, it is difficult.
No, sir.
It is impossible. First, in order to push the piston upward direction, the gas must be heated. The gas must be heated means its temperature has to be raised. The temperature has to be raised means some of the heat which has to be absorbed by the system to increase its temperature. So when the temperature is changing, it means definitely internal energy of the system is also changes. That is happened due to the heat absorption. Like the amount of the heat is absorbed by the system means first a part of the supplied heat is utilized to increase the internal energy. The rest of the supplied heat energy is used to do the work. Hence, the heat supplied to the system, which is capable of doing work, is always equal to the change in internal energy of the system and work done by the system. Then the first law of thermodynamics, basically we can write dq that's equals to du plus dw. We can write dq that's equals to du plus dw. So dq is the heat supplied to the system. So du that's equal to change in internal energy of the system. That is nothing but the heat is supplied means du is increases, and dw is the work done by the system. So this is about the first law of thermodynamics. On what basis the first law will be about? On what is the basis of the first law will be?
Internal energy.
Internal energy. Next, this is the word. This is the heat. First law is nothing but conservation of energy. First law of thermodynamics will be on conservation of energy. Second law of thermodynamics is nothing but transfer of heat energy, okay, which is on the basis of transfer of heat energy or thermal equilibrium. Second law, first law of thermodynamics is on the basis of conservation of energy. dq is the heat energy which we are going to supply, that is equal to sum of the increase in internal energy and work done means this energy is nothing but sum means just energy is transferring from one form to another form. That's why first law of thermodynamics is on the basis of conservation of energy. So this is about the first law of thermodynamics. Okay, so make a note. Don't write anything. This is I'll dictate the note. Right. First law of thermodynamics. First law of thermodynamics. Okay, na?
Yes, sir.
Yeah. So write it. First law of thermodynamics. The heat supplied to a system, heat supplied to a system which is capable of doing work, is equals to the sum of the sum of increasing internal energy of the system, increasing internal energy of the system, the sum of increasing internal energy of the system, sum of increasing internal energy of the system, increasing internal energy of the system, and the external work done by it, and the external work done by it, and the external work done by it. You can write here dq equals to du plus dw. dq is equals to du plus dw. dq equals to du plus dw. dq equals to du plus dw. Okay. So next in that only you can write the sign convention. Sign convention. Sign convention. Okay, sign convention. So dq is positive when heat is given to the system. When heat is given to the system, dq will be taken as positive. Next, dq is negative when heat is taken back from the system. Okay, taken back from the system. So simple thing, you have supplied the heat energy to the system. On such case, dq is positive. If you have extract the heat energy from the system, on such case dq is negative. Students, tell me one simple example when dq is taken back from the system. Any one simple example which we have already discussed. Any one simple example, students. No idea? Anyone? So, what is an example means freezing of ice. If you keep the water inside the refrigerator, then in order to freeze the ice, what it must be? We need to extract the heat energy from the water, then only water gets freezed into ice. On such particular cases, you are extracting the heat energy from the system. On such cases, dq can be taken as negative. For example, if you take the same ice, in order to melt the ice, what we need to heat up that ice. On such
This is
case,
positive.
supplying the heat energy to the system, that is not possible. So, got it this one?
Yes, sir, got it.
Yeah. So next one, 3, 6 are there. Next, du is positive. So the du is positive. When it will be du is positive? Du is positive. Already they have written earlier. Internal energy. When the temperature of the system is
Increase.
yes, increases. Okay, so du is positive when internal energy is increased. Internal energy is increasing. du is positive when internal energy is increased. Next, du is negative when internal energy is decreased. When internal energy is decreased, du is negative when internal energy is decreased. So next dw, okay, so this is nothing but work done. dw is positive, okay, when work is done by the system, work is done by the system, and dw is negative when work is done, sorry, work is done on the system. Okay, so dw will be taken as positive when work is done by the system. What it means by done by the system means this is nothing but expansion. If the system is expanded, then we can say that the work is done by the system, and dw is negative when work is done on the system. Here we can say that what is here we can say that this is compression. This is compression. dw is negative. So these are the sign conventions we need to follow while we are using the first law of thermodynamics. dq can be positive, can be negative. Similarly, du and similarly dw is also. When it will be positive, when it will be negative means if you have supplied the heat energy to the system, then dq must be taken as positive. When we are extract the heat from the system, on such case dq can be taken as negative. And if you increase the internal energy, the temperature is increased means internal energy of the system is increased, the change will be positive. Already we have noticed that earlier. And similarly, du is negative when the internal energy of the system is decreased. dw already this is also we have done. Work is done by the system means the system is expanding. Work is done on the system means the system is compression. So make a note of this. Completed, Amma?
Yes, sir.
So this is regarding yeah. First law of thermodynamics. Okay. So let us go with one or two numericals. So how to use this? So please note down the numericals. Okay, na? Can we dictate the numerical?
Yes.
Yeah. The heat energy of 1500 joule. The heat energy of 1500 joule. The heat energy of 1500 joules is supplied to the system so that it does it so that it did 525 joule of work. So that it did 525 joule of work. 525 joule of work 525 joule of work. What is the change in internal energy? What is the change in internal energy? What is the change in internal energy? Change in internal energy. Okay. So please go to that question once. What they are given in the question first. So 1500 joule of heat energy supplied, so that it did 525 joule of work means it did means what system did. System did the work means first dq is equals to what can we take? dq that is equals plus 1500 or minus 1500?
Plus 1500.
Plus
Yes.
1500, sir.
Yes, plus 1500 because heat is supplied to the system or like heat plus only. Okay. And dW is equals to 525. Is
Plus
it
525, sir.
plus or minus? 525 is okay, plus or minus?
Plus, sir.
Sir,
It did.
plus.
Yes, plus because system did the work means work is done by the system. On such case, this is 525 joule. This is also joule. And change in internal energy, dU is question mark. From first law of thermodynamics, we wrote dQ is equals to dU plus dW. That implies dW is equals to what can be written as dU that's equal to V1 dU. Keep dU one side and remaining comes on other side. dU that's equals to dQ minus dW. dU that's equals to dQ minus dW. So that implies dU that's equals to dQ means I can write 1500 minus dW means 525. So what is the dU? dU
975 joules, sir.
975 joules.
25 or 75?
25, sir. 75.
75.
975 joules. We got plus 90 plus 975 or minus 975?
Plus 975,
Plus
sir.
995 means internal energy of the system is increasing. Instead of plus, if we would have got minus means then one has to understand that internal energy of the system is decreasing. Okay. So here plus means it is increased. So you try it this summer. So students, you try this problem. Okay, you try this problem. So calculate the external work done by the system. Calculate the external work done by the system in what is kcal means kilocalories. Answer must be in kilocalories. Calculate the work done by the system in kilocalorie when 40 kilocalorie of heat 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 is supplied to the system. 40 kilocalorie of heat is supplied to the system comma 8400 joule 8400 joule of internal work is done. 8400 joule of internal work is done. 8400 joules of internal work is done. Okay. So let me repeat the question. Calculate the external work done by the system in kilocalorie when 40 kilocalorie of heat is supplied to the system, 8400 joule of internal work is done.
Sir,
Clear?
internal work is nothing but internal energy, sir.
Yeah, that's what. Answer must be in 38 kilocalorie. Amma. Answer is 38 kilocalorie. So try it. It is simple only. The same thing what we have done in similar model. So in tomorrow's class we will see about the specifics of gases and.
Sir, joules should be converted into calories, no, sir?
Yeah, yeah, answer must be in calorie. The 8,400 we need to convert into kilocalories. Okay, right?
Okay, sir.
Yeah, so that's it. See you on next class. You try those problems. Okay, okay, guys.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.
Thank you, sir.
Ah, yes, yes, yes. Bye.